Hey, today we're going to dive into something crucial for data scientists, the software engineering skills that can really help you shine in production environments. Let's get started.
Hi, I'm Dr. Chris, and I'm happy to share my experience in DevOps Cloud and data engineering with you on my channel.
So why does this matter? Well, it's about building systems that scale, collaborating better with engineers, and actually seeing your work go from a cool idea to something that makes an impact in production. Let's explore how. Let's be real. Many data scientist projects start by copy-pasting Python code from various sources. We often find ourselves hacking through Jupyter notebooks, applying quixes and transformations. And yeah, sometimes the code is written just to solve one specific problem without thinking about reusability or future needs. It works in the moment, but we all know it's not scalable or maintainable in the long run. First, one of the biggest limitations of this work mode is the lack of reusability. When code is written for just one purpose, tough to use it again, other tasks. Instead of writing reusable functions, we often end up copying and pasting, which wastes time and leads to duplicated efforts. Then, there's the issue of maintainability. When you're quickly hacking together transformations in a notebook, code can get messy fast. Over time, it becomes harder to fix or extend, especially if the project gets more complex or larger in scope. Scalability is another major problem. Code that works fine for a small dataset can really struggle when the dataset grows. Suddenly, you're dealing with performance bottlenecks that slow everything down, and you're stuck rewriting code to handle larger workloads. Collaboration is also a challenge. When your code is unstructured or lacks comments, it's almost impossible for others to understand what you've done. This makes it tough for anyone else to contribute, leading to silos where only you know how the code works. Lastly, one of the biggest risks is not having proper testing in place. When we skip writing tests, bugs and errors can easily slip through, leading to unreliable results. Without tests, you can never be 100% confident your code will work as expected, especially when things go to production. So it's clear, current way of working is holding us back. As projects grow and get more complex, we run into roadblocks like scalability, maintainability, and collaboration. It's time to shift towards something better, something that lets us work smarter, not harder. The good news? There's a solution to all these problems. Best practices from software engineering. By applying structured coding practices, we can make our work more scalable, easier to maintain, and much more collaborative. Combining data science with software engineering is the key to unlocking its full potential. First up, version control with Git. If you're working with others, this is a game changer. It helps you track changes, experiment safely, and collaborate smoothly on big projects. Once you start using it, you'll never look back. Clean and modular code sounds simple, right? But it's a total game changer. Creating code that's easy to understand and reuse will make life easier for you and anyone working with your code. Plus, things organized, and that's always a win. Testing and debugging. I know, it sounds tedious. Trust me, this is the key to writing reliable code. When your models are well tested, you can trust them in any situation. Debugging, well, that's your superpower when things don't work as planned. Now, collaborating with software engineers comes so much easier when you speak their language. Understanding APIs and how software development works will help you get your models into production without a hitch. Teamwork makes the dream work. Code performance optimization is where you can really flex your skills. You've got those huge data sets. Now let's make sure your code runs efficiently, both in speed and memory. Being able to identify bottlenecks makes you unstoppable. Deployment and automation. It's all about making your models live and keeping them there. Tools like Docker and CI/CD pipelines, they make sure everything runs smoothly so your models can keep learning and performing without a hitch. Ever heard of software design patterns? They're like a blueprint for your code. Knowing patterns like MVC helps you build systems that are easy to manage, especially as your projects grow. Nobody wants their code to turn into a mess of spaghetti. Security and data privacy aren't just for engineers. If you're handling sensitive data, you need to be on top of encryption and privacy regulations like GDPR. And don't forget about bias. Build models that are ethical and fair. All right, wrap this up. Data science and software engineering go hand in hand. If you master these principles, you're setting yourself up for success. Scalable, maintainable, and impactful. That's what we're aiming for. So next, take action. innovation. Start putting these practices into your workflow. Your prototypes can become production-ready solutions, and the future, it belongs to those who master both data science and software engineering. You've got this. Thanks for watching. I'd love to hear your thoughts. Are you a data scientist, a software engineer, or a mix of both? Share your experiences in the comments. Don't miss my other videos about DevOps, cloud, and data engineering. Support me by subscribing to my channel.